Okay. All right. Well, welcome everyone. Welcome to today's delegate assembly. As you've joined, we are now recording. Today I will be presenting on how to use TOPCAT with the DP0.2 tap service. Melissa just tested the tap service. There were some issues last time, but it seems to be working well now, which is good. Otherwise, we would not go too far. Let's see. So announcements. We will have. Okay, let me slow down here. I tend to talk too quickly. So let's see. For the agenda day, we have announcements now. We'll have a presentation, and then we'll have breakouts at the top of the next hour. So for the announcements, we'd like you to think about breakout topics for the second hour. Currently, we will probably leave the main room open for general Q&A. We might do like science with LTC light curves. I think we have any new delegates. I'm not sure. Oh, I think Alan Smith is on. He's not a new delegate, but hasn't attended these sessions too often. There's the white dwarf photometric classification that I know Bob's been looking at that. Any other suggestions? We'll come back to this after the presentations. But we will also, hopefully, most of you have TOPCAT installed. We're not going to focus on that because that takes a lot of time. If you don't, so you can just kind of follow along. Those who have TOPCAT can follow along interactively. Those who do not have TOPCAT installed, we'll be providing some help with installation and using TOPCAT as a breakout session in the second hour. And we may also have some time to talk about how to use the DP0.2 tap service with PyVO in the second hour, in the breakout in the second hour. Let's see. We will have. Oh, I should put this in the this link in the. Oops. I should put the link to this in the chat so you can access this. Where is my chat? My chat has disappeared. Here, it's hiding down here. Chat. Okay. I'll add the link to the slide, link here, and I will also, as we go on, add other links. So if you go to the second page, this is a link you can link to the first presentation and the second presentation. We'll first talk about the general RSP API aspect, and then we'll do a tutorial on using TOPCAT to generate a bright stars color magnitude diagram with from the DP0.2 database with TOPCAT. We do so future DP0 virtual seminars. There's a Stack Club plan for next Friday, but then we will take a break until February. We are definitely eager to hear from you if you want to give a presentation. And if you wish to give a presentation, please volunteer by contacting Melissa at this email address here. All right. I will now. Okay, so let's start with the first the first presentation was actually, I just wanted to go through some discussion of the RSP IPA aspect. And actually, so first of all, when you go when you and actually if you go when you go to data.lsd.cloud, you're presented with this page, and one of these items is the APIs. We've been looking at the portal aspect and the notebook aspect before, but we've not really covered APIs. Um, um, so what? First of all, what is an API? An API is a oh, I forgot the acronym. One second. It's an application programming interface. It allows you to. It's an interface between two pieces of software. Allows them to communicate. We've and TAP is one of those. TAP allows you to query um, query catalogs and do basically and do 80 QL queries, or basically sort of like SQL queries. We've seen these. Uh, um, we've seen these too before. Actually, when you use a notebook, when you use a Jupyter notebook on the RSP, on the Ruben Science platform, there some of the details are hidden because we have a wrapper around some of the details by using the LSST RSP module to get the get tap service, and then you can command and the retrieve query command, which are part of a wrapper around a lot of details. So when you're running the RSP, you're kind of a lot of the details are hidden from you because you don't. But we'll see some of the more details later. But for the notebooks, I mean, you use the get tap service to gain access to the service. You prepare a ADQL query. In this case, we're selecting the top 100 objects from the DP0.2 object catalog. You request a search on that query, and this may take some time. And then the search returns the set of results, which you then can convert into a AstroPy table or even a pandas data frame. And so there's several DP0 notebook tutorials that demonstrate the use of this. What we are going to look at, however, is how to use TOPCAT on your own computer to access the RSP service. Now, to do so, TOPCAT is a popular and useful graphical utility that was produced as part of the International Virtual Observatory Program, and it's still actively developed by Mark Taylor, who's the programmer for TOPCAT. We won't go through all the details here because there's so much for TOPCAT. But if you want to use TOPCAT with the DP0.2, you need to have a token to access that. And I will show you here how to do that. Here are the step-by-step instructions. We will, but first of all, we need to create a token. And this token, you should treat it like a password. You don't want to give it to other people. You don't want to have it open in a place where people can see it. You want to treat it as a password. So you want to keep it secret. How do you generate a token though? Well, first of all, let's see. So there's a link here, and thank you, Melissa. Melissa's put a link on how to create user tokens. You can click here. I will show you. I'll actually just show you step by step by going to. First of all, I need to. Okay. People should log in to their. If they're not logged in already, you should log in to the RSP at data.lsst.cloud. and I'm at my credentials are through Fermilab, so I'll log on this way and continue. Oh, and I need to open up my password manager, and let's see, sign on. And all right, so I'm signed on, which you can tell because my username is up here where login used to be. For those who are following along, are people logged in? Okay, I think Alan might be having a little trouble, but we can come back to that later. We can do that in the breakout session if necessary.
Yeah, I'm just lurking because I'm going to have to leave in about 10 minutes anyway.
Okay, all right.
But I see you're recording it, so I'll go through this in gory detail later.
All right, okay. Anyone else having problems? All right. So, okay, let's continue. Okay, we will create a token. So you go to go here to your user location, your username here, and you go to security tokens, and that opens up this. Now, you may not have anything in this section, or maybe just or you may have like my token. But this is where you create a token. You go to this create token button, and let's have it. And you want to give this token a name because you can reuse it later on. You don't have to create a token every time. You can reuse a one that you created before. So I usually call it something like TOPCAT token. I actually have a whole bunch of these. But I don't really need a bunch of these. I just think it's kind of accumulate. So I kind of give it. I want to know that there's a TOPCAT token, and I give a date when I created it. And you want to give it a scope of read tap. So you want to check this read tap for execute select queries in the tap interface on project data sets. And for expiration, I recommend just saying never. You can choose a lifetime or expiration date, but I think ideally you just set it to never and then hit create. Now, this is very important. Do not hit OK yet. What you want to do is, and I will move this slightly out of the way. Okay. So, okay, I'm going to have to delete this token later on because it's going to be recorded. So, and I don't want to do that. But for the purpose of this session, I will keep this. You can see my token. Don't use my token. Use your own token. I'm going to copy it over here for a second. So so you want to copy it into like a file or something so you can save it for later on. And once you've done that, then you can hit OK. But make sure that you've copied it, because you'll never see it, as it says here, you'll never be able to see this token again once you've hit OK. And then you have to create another one. And it's listed here. You don't have the fulls. You don't get the full. You don't get the full string. Okay. So now we have created. Oh, sorry. Yes.
We delete that right away.
Sorry.
Can we just delete it right now so that we don't have to cut that part of the video out and there's zero chance of forgetting later? Can we just click the trash can button there while it's up?
Okay. but there'll be other times when it will, okay, I'll do that, but, okay.
Because we usually post the link to the video immediately after, and I don't want to have to remember to wait or remember to cut it out or anything. So we just
Yeah,
delete it.
okay. All right, I do have other tokens, which, and these you can't, which I'll use another token when we get to the next step. So then I'll have to delete that one too, probably. Anyway, okay, so okay, now you have a token, and now we want to open up TOPCAT, and I'm going to move this a little bit out of the way so we can see. Okay, I'll clear this. Okay, so everyone has a different way of opening TOPCAT. I usually prefer one of the jar method, one of the command line methods. If you're using Mac OS, there's also one where you just click on an icon. Open up your TOPCAT session, however you do that. And you will get the main TOPCAT window. Now to access DP0.2, you need to go to the VO interface. Now on Linux systems, I think this is actually part of the set of menu items are actually part of the main TOPCAT window. For Mac OS. It's part of the background screen. But go to the VO menu, and there is something called Table Access Protocol or TAP Query. There's a menu item there, which I have highlighted. And once you highlight it, click it, and it will. Okay, it's opening on a separate screen here. Sorry about that, but this other screen has a better resolution for these views. So it will open this TAP Access Protocol TAP Query window, and you'll see here there's actually all sorts of TAP services available. But we won't click on those at the moment. We're not looking at these at the moment. But for future reference, there's a lot of different TAP services which are open access. You don't need to have a token or anything for these, including Gaia and HST and so on. But what we want to do is we want to okay, come back here. We started up TOPCAT. We've done this. Okay, we want to fill in this TAP URL with the DP0.2 your TAP API access URL, which is this, and we can cut and paste that here. I'll also note as an aside for those who want to use larger than DP0.3, you can use this other URL. Like here, we're just focusing on DP0.2. So you stick that in the TAP URL and you click on Use Service. And that will open up this authentication window. And this is where your token, this is where you put your token. First of all, for the user, you want to cut and paste this username x-oauth -basic. You put that in for the user. And then for the password, you use your, you grab, okay, I'm gonna have to grab, I have this saved elsewhere.
If you just stop screen share while you enter your token as the password, then you won't use another token.
Oh, no, I think it's all right. You won't see it because it'll be all dotted out.
Okay.
or I could do a quick test. Yeah, it'll all be dotted out. Okay, I have it in another screen, and I will, and you just stick your token in for the password, and you hit OK. And how do you tell if it worked? Well, in this TAP Access Protocol Query window, in its metadata panel, you'll suddenly see that there are all these DP0.1 and DP0.2 catalogs that are now visible. And there's some other stuff about the TAP schema and other things. Now, DP0.1 is deprecated. We don't suggest looking at that, but it is there for historical reasons. But we will, for the next steps, we will be looking at primarily the DP0.2 object catalog. Now, you can adjust the size. You can drag and click panels and windows to resize them. So that's what I'm doing here. I'm resizing this, and will be interested in this DP0.2 object catalog. And that is actually the end of this first part of the tutorial. So are there any questions? Is everyone who's trying to keep up caught up? Are you able to get to this screen? All right. Okay, let's move on. So we will, and actually the next part is actually listed under section 6 of this current tutorial. You can either click on here, or I can actually just add. I can put this in the chat window. So, oops, I lost my cursor. 1 second. Here it is. Okay. So, all right. So here we are partly we're following the tradition that was started with the notebooks, the Jupyter notebooks, and the portal in our first tutorial at the moment, but only API TOPCAT tutorial, is to look at bright stars, create a bright star color magnitude diagram from DP0.2. So this partly mimics the introduction to Jupyter notebooks for data preview 0.2 notebook, and the Portal tutorial, and the first Portal tutorial, Bright Star Color Magnitude Diagram Beginner. In fact, that's almost the same name. It should be noted that all the functionality demonstrated in the first 3 examples below is possible through the RSP portal aspect, but we do go a little bit beyond. In example 4, we will look at interactive 3D plots. And also, I was noted that these examples tend to build upon each other. So if you're doing this on your own, you may want to start from the beginning. First step, we've already actually accomplished. We started up TOPCAT, and we've are looking at the TAP Access Protocol Query Box window, and we resize we resize things as we like. The next step is, let's just do a simple query. So in step 1.2, there's this query which basically just grabs the ARI index, the detect is primary flag, a couple R-band fluxes, and the R-band extended parameter for a 0.1 degree radius circle that's more or less centered in the DP0.2 footprint at an RA of 62 and a deck of minus 37. So let us grab, you can cut and paste this, you can copy and paste this, you can select this, and you want to go over here to the ADQL text panel, and you want to insert it here. So everyone caught up at that stage? All right, and once you've done that, you want to hit the Run Query button. And you'll note, and actually this is shown in step 1.4 here, that you now have a table in the table list panel of the main TOPCAT window. It's here, it's highlighted in blue. Now, let's say we want to take a look at this table. It's a very short table, a very small table, only 10 only selected 10 objects, so it'll be 10 rows, and there's what, 1, 2, 3, 4, there's 5 columns. So we can go to the display cell table, table cell data icon in its upper row. So it's the 4th one over here. It looks like a little Excel table with a grayed out top row and first column, and you want to click on that. And here is your table. You have 10 entries, as we requested, of ARIA and DEC. The detect is primary flag, the R calib flux, and the RC model flux, and the extendedness parameter. So has everyone gotten that? Any problems? All right, so that is actually the sum of the example 1, is just to do a simple query. The second example is we'll run a much more detailed query. So you can, if you want, close this window using the X, because we won't be looking at that one again. So the next query, we will do another query in the so this next query, we're basically collecting the ARIA and DEC and the U-band and the calib flux and the calib flux error for all 6 filter bands. And we are once again selecting a circular area near the center of the DP0.2 data set. Oh, sorry, there's a question back to the previous item. Let me just quickly go back. The blue numbers, so I'm in the same. Let's see. Okay, yeah, sorry, let's go back. So I think Tom answered that question. The blue.
I'm just
numbers-
asking about the
these numbers. This is recording memory usage.
That's what I was guessing. Yeah,
Yeah,
'cause
yeah,
very different. So
yeah. So
so I'm
Yeah.
not worried. I'm just curious.
Generally, you don't have to worry about this too much, except when you're doing really big tables. Right now, I have a gate using an 8 gigabyte processor, and a very minimal amount of memory is being used at the moment.
And by default, it's not, the container size is not 8 gigs, right? That's a option that you can set, that there are instructions for in the TOPCAT documentation.
That's true. That's true. You can make it larger or smaller, but in my case, for my processor, it chose that automatically.
I'm on a Mac
If
and
you have
it created a huge one by default. So
Mhm.
thank you.
All right. Oh yeah, no problem, no problem. Oh, okay. So so back to this new query. So we'll just get rid of this other query. There's various ways you can get rid of it. You can just you can either select it all and then hit delete on your keyboard. There's a little eraser here that I can use to delete that. And we'll fill in this other query, and I'll explain that query in a second. So we're grabbing the sky coordinates in RA and DEC and the calibrated flux and the calibrated flux error for all filters within a 1 degree diameter circle centered at RA of 62 degrees and a DEC of minus 35 degrees. And we want star-like. We want to use the primary objects. We don't want secondary objects. So we set the tech is primary equals 1. We want star-like objects. So we want the extendedness not to be. We want the extendedness to be 0, not 1. And we want moderately bright objects. So we choose as chosen in like the similar tutorial in the portal and the notebook. We choose 360 nanojanskis as the lower limit for our fluxes, and we set the top 10,000. As it turns out, there's only about 75 or 7,600 objects returned anyway, so the top actually is not necessary in this particular case. But okay, so once you have that here, you can go back to run query, and you'll probably have something called a load table that pop up on the screen briefly and then disappear, and then you'll have a new table under your table list. And as a brief aside, you can also change the label by by typing in here. So see, I added 2, and there's a 2 there, and you can remove it too, or you can change it whatever. But anyway, so there's 7,555 7 rows returned and 14 columns. Following what we did in the previous example, we can take a look at that at the table by clicking on this icon here, the one with the display cell table table cell data icon here. And you'll note this is a much bigger table. So there's scroll bars, horizontal and vertical scroll bars. Actually, it's not something that you can actually make it wide enough that you can see everything here. And there's 7,557 rows returned. All right, let's so that is good. Let's see. Now we can also look at information about the columns. In addition to just looking at the metadata for the columns. So we can go to this next icon, which has which looks like an Excel spreadsheet, but with the upper row all colored in blue to display the metadata information from the columns. And here we have that. There's a lot of data information here. There's the name of the column. You can also use like numerical designations for the columns if you don't want to use the name. The class and data type of the variable, the units, and the description. And here you see that the fluxes are all in nanojanskis and the R in degrees. Okay, now we're going to do a little, we want to convert these fluxes into into magnitudes, and further into AB magnitudes. And there's a simple equation for converting AB magnitudes in from Nanojanskis into convert a flux of Nanojanskis into AB magnitudes, and it's this equation here, minus 2.5 times the common log of the flux plus a 0.31.4. How do we do this? You can actually do this in different ways, but what we'll do here is we'll add columns to our table, and we can do that by going to this big green plus sign, and that will open up this define synthetic column window. And here we come to kind of the most onerous part of the tutorial, of a lot of cutting and pasting. So we will create. We'll insert U. We'll start with the first U band. We'll do U. We'll kind of copy and paste U _ Calib mag into the name. Oh, Tom, which tool brought that up? So you want to go to the icon with the blue, that looks like an Excel spreadsheet with the top row all in blue. It's the fifth, 1, 2, 3, 4, 5. I guess it's the sixth icon in this list here. And then you'll click on, and then it'll open up this window, and you want to click on the big green arrow.
Thanks.
Big plus sign.
Thanks.
Yeah. Follow what I mean, not what I say. Yes, it's the arrow. Okay.
Typing some.
And that'll open up this, and then you can cut and paste the expression here. Optionally, you may also add in the units and a description. I will generally not do this because this is kind of a time-consuming step, and it's not really required for the rest, but I'll show it for the U band here. But I won't do it for the other filters. But you can add that here, and you'll notice it appears at the bottom of this metadata window. And let's see, let's spread this out so we can see the expression. And also, if we move this out of the way, and we come here, you'll see it now appears as the final column in our table. Now we may let's also include the magnitude error for U band. So recall that magnitudes are a logarithmic function. They do have a nice property that magnitudes have a nice property that if you're like below 0.1, 0.2 magnitudes, that is almost directly related to the percentage. So it's an error of 0.08 mags is basically roughly 8% error. If you run through the propagation of error analysis, the exact equation for at least these relatively small errors is 2.5 over the natural log of 10 times the error in the flux over the flux, which can be approximated by this equation of error in the magnitude is 1.086 times the error in the flux over the flux. So do the same thing here. Hit the plus, hit the green plus sign. Here we'll call this U Calib mag error. And we will copy and paste this equation over into the expression. And here we'll just be lazy and we'll ignore the units and description. They're not really necessary. It's you can optionally add in the units will be magnitudes and add in a description. And we'll hit OK here. And now the error is added to this list. And if you go to the metadata, and if you go to the actual table, you'll see that the error is now at the final column. And you'll also kind of notice that they are pretty small generally. They're there's okay, here's one that's pretty high. It's 0.27 magnitudes, but most of them are 0.03-ish, 0.02 level or smaller. I guess if you get really faint things, they'll blow up, as we'll see later on. Okay. The next step is really the onerous part. We're gonna we will add we will add the magnitudes for all the other filters, and just to save time, we'll just do the G band error. But let's just first of all, ideally, if you're on your own, you guys do all of them so you can play around with things. But to save a little time, we'll just at the moment, I will just add the magnitudes for the rest of the filters, and the error for just one more filter. So it's all cut and paste here. We'll do G Calib mag, and we can cut and paste that here. And okay, and I'll just do one more error, and then the rest will be just the magnitudes. So I'll hit a big plus sign and G Calib mag error, and the expression is this one. Okay. And now for the rest, I'll ignore the errors just to save a little time, but I'll do the rest of the magnitudes. And so R Calib mag. And like I said, I'll skip the errors from the rest, but I'll do the rest of the mags. Okay. Oh yes, yes. So Jeff has a nice thing in the notes. I didn't want to go into that particularly, but you can. There is actually a special function that will convert from Jansky's to AB magnitudes in TOPCAT. Well, let's see. I need IBAN. Z. Calib, oops. Z Calib mag. And finally, Y. Calib mag. And actually here, I'm going to intentionally make a mistake. I'll do that just to show you something just a little separate. You can also edit things in this column, in this table, in this metadata window, and say, oops, I misnamed that. So I can click on it and click on that column and fix it. You can also do the same thing. Oh, and I also put the wrong equation here. I can delete that and put the right equation here. Okay, so now we've got things all set up for the rest of the for the rest of the tutorial. Okay, so we can look again at the table, and we'll see that we now have all those filters, all the magnitudes for all those filters now listed. And now we can do some plots. So first we'll do a plane plot. So you can go here and go to your main TOPCAT window, and you'll go along this top row, and you'll find this icon that looks like a Cartesian plane plot, and you'll click on that, and it will open this, and it will automatically choose the first two columns which have numerical values in it. If you have a string value, if you have a column as a string value in it, it'll ignore that. In this case, it's ARIA and DEC, and you get basically a sky plot of this. What we want to do, however, is we want to do a color magnitude plot. So we want to plot. So down here we'll switch the X and Y to the values here in step 214. We will replace the RA, for the value of the X, with R calib mag minus I calib mag, and we'll replace the Y-axis value column with the G calib mag. And here you have the first instance of a color magnitude diagram. Now, astronomers usually, so here, blue is over here, red is over here. Small mags are brighter. Bright is down here. Faint is up here. Astronomers usually like to have this axis flipped, and we can do that. You can do that if you go over here and click on that axes button, and it opens up this this new panel here, and you can click on Y flip, and now it's flipped. Now the bright small magnitudes or bright objects are at the top, and faint objects or higher magnitude objects are at the bottom. And then finally, for this part of this example, we can, to guide the eye, we can go add a grid. So you can go along here and click on grid, and you can click on draw grid, and now you have a grid. All right. And that's actually that's the end of that's basically the end of example 3. There's more that you can do. You can try other colors and magnitudes to explore on your own, but we'll move on to example 3. But first of all, are there any questions about example 2? All right, let's move on to example 3. This will highlight, we'll create a couple different different additional plots, and we'll show that we'll show how to interact with multiple plots from the same table. So I'll move this over here slightly. Well, you'll want to make sure that once again your second table is highlighted, because we want to use this table, not the other table. And the first thing we'll do a sky plot. We actually saw sort of a sky plot just before in the previous example. There's actually a special functionality for doing sky plots in particular, and that is, you go to this top row, you go to this little sky plotting icon, which sort of looks like a sky plot projection, and you click on that. And TOPCAT is pretty good about finding, identifying RA and DEC columns. And in this case, it chose the right ones. It chose coord RA and coord DEC. And so it doesn't always, and you might need to change things later on. But in this case, it chose the right thing. In this case, it's in sexagesimal units, so it's RA in hours, minutes, seconds, and degrees, and DEC is in degrees, minutes. You can change that. We won't go in that. We can discuss that later, maybe in the breakout session, how to change things in some of these plots. But here we just want to have the plot open. And then let's make another plane. Let's make another plane plot, and that's in step 3.4 and step 3.4. We will let us go here and click on the plane plot icon. And okay, now you see it grabs the first two numerical columns, but we want to change. We'll change those. And we'll change the. We'll replace the X with the G band calibrated magnitude, and we'll change the Y with the error, with the G calib mag error. All right, and let's and let's in step 3.5, we'll just try to just maneuver things around so you can see all these windows together. I'll kind of cover that up temporarily. And we have this window. We have this window. And we want to, let's make sure that we have the table browser also up. We put this down at the bottom. Okay, let's see. Oops. All right, make this kind of adjust things. It's a little messy, but that's fine. Adjust the size a little bit. Okay, so now you have all these windows up, and you have the table up. Let's say you're curious about one of these objects. Say you're looking here, and you see this object at 24th magnitude and about R minus I of 1. If you click on that, you'll notice that there's a little circle with crosshairs that appears around that. You'll also notice a circle with crosshairs pops up in these other two windows. That is the same. Those are data from the same data point, the same row. That's the same object in all those plots. Furthermore, it is also, the row is also highlighted. And you can also do it the other way around. You can also just choose a table entry at random, and it will show in each of these plots. All right. Let's see. Are there any questions at this point? All right. Melissa, is it all right if I go slightly over to cover the next example? Because we're getting close to the hour.
Yeah, I think that's fine. If anyone has any questions, like if you have to leave at 10 and you've got questions or it didn't work for you, let us know. And otherwise, if you have to leave now, we understand. But yeah, we can keep going.
Okay, it won't take too. I won't go. I shouldn't be able. I shouldn't go over. I don't think I'll go over too long. But let's go on to example 4. And I guess if you want, you can move these. You can move these out of the way. You can put them in the background or close them. Don't close the main window though. Well, let's focus on the main window. And actually, we can remove that out of the way too. Let's go back to the main window. Now we're going to look at some 3D plots. We're going to create interactive 3D plots. So, and we'll continue to use this second table here. So, so get to this point where you're at main TOPCAT window and ensure that this table is highlighted. And then in step 4.3, what we'll do is we'll go to this icon here. It looks like a 2D representation of a cube. And you will want to click on that. And like with the example 2, it will plot in this case, it'll plot the first three numerical columns in the table, which in this case is the RA and the DEC and the U-band flux, U-band catalog flux. But we want to do color. In this case, we'll do color, and then a color diagram. So what we'll do is we will replace the X with R minus I in the calibrated magnitudes. So R calamag minus I calamag. And for Y, we'll do G calamag minus R calamag. And finally, we will do U calamag minus G calamag. And now you see a star locus in 3 dimensions. It's the U, the R minus I is the X, the G minus R is the Y, and the U minus G is the Z coordinate. But we can actually do more. Oh, and you can also see yeah, I forgot to mention it before in example 2, but these red objects, they're quantized due to the colors are quantized due to how the simulation created those very red stars. It's not you won't see that in the real Rubin data, unless the universe is very weird. We're now looking at 3 dimensions of information. We can add a 4th dimension by color coding each point. And how do we do that? Well, we can go here, go to the bottom, this bottom panel here, and see where it says form. You can click on form. And let me broaden this a little bit. Now it gives the shading mode as flat. So that's just basically, so here, but you can change that shading. So you can do like translucent, and now you kind of see things are translucent. You kind of see the where things are more heavily populated, areas where the plot is more heavily populated are darker, and where less populated, the symbols are less dark. There's other things. Transparency does something similar. Density does something similar. There's some variations, but what we're going to look at here is the auxiliary or aux. When you click on that, it adds a color bar on the side. Right now, there's nothing pointed at that color bars. So here we want to choose what we want to use to be plotted by the color bar. And what we'll do here is we'll use let's use the I band, where is it? I band magnitude, I column magnitude. And now you see the objects are color coded. Each symbol is color coded by its I band column mag. And it ranges from of about 16th magnitude, about 25th magnitude, from kind of a brightest yellow to a dark brownish black. Now, say you don't like this particular color map, you can change that, and that's what we do in step 4.4. And we do that by going to this aux axis button over here on this left panel. And here you see that the shader here that is used is the Inferno shader, but there are many different different ways of shading things. Let's just go with a rainbow. And here we see now that are color coded by the colors of the rainbow from indigo, violet to red. And actually, I don't have it. It's notice in the tutorial per se, but you can also flip the shader too. Now, finally, and I think some of you probably already tested this out already. This is an interactive plot. You can click and drag, and so you can click on a point in there, and you can rotate it and see different aspects of it using your mouse or your trackpad. You can also use the scroll bar to zoom in and out. And so on. And so, and then the rest is optional exploration. Say you want to add, say for instance, instead of color code by IMAT, you'd add another color. You do say Z minus Y. That's not very interesting. I wonder what's. Oh, let's do. I don't know what's going on there. Let's do I minus Z. So you see, you have another. So now you have a color diagram for your data set. And with that, that's it for this tutorial. We could discuss more about if people who want to don't have TOPCAT installed but want TOPCAT installed. We have a breakout session for that, which will also discuss additional ways of other options for other things you can do with TOPCAT. We can also discuss PyVO and how to do things with PyVO. But before closing, any questions at all about what we've shown here? All right. Okay, I will let me switch back to. Oh, Tom has a more interesting. I probably did have a typo, and we can actually even check that. Let's see why then. Oh, there was a typo. I had Z-band, and you can fix that here. So thanks, Tom. Okay, so here I correct Z-band. And if I go, and so actually that Z-band is really not, we can do Z minus Y. So yeah, that's a little bit more interesting. All right. So let's yeah, go back to yes. All right. Let's see. So breakout sessions. Why don't we have one for installing and using TOPCAT and accessing the DP0.2 TAP service with PyBO. Are there other and we'll leave the main room open for general Q&A. Are there any other topics, breakouts rooms people would like on the white dwarf photometric classification or other things? Okay, we do have one for white dwarf classification.
Thank you.
Maybe that can be item one. Breakout room. Oops, that'll be breakout room Z minus Callum.